Namaskar students. In last video, we have discussed some applications of differential equations, like applications in electric circuits, then Newton's law of cooling, heat flow, and for finding orthogonal trajectories. Now, we will do some problems. So, let us consider one problem. The problem is a cup of coffee at a temperature 100 degrees centigrade is placed in a room whose temperature is 15 degree centigrade and it cools to 60 degree centigrade in 5 minutes. Find its temperature after a further interval of 5 minutes. So this is a problem which we have to solve here. Now let us read this problem carefully. A cup of coffee at a temperature 100 degree centigrade. So we are talking here about a cup of coffee. We are talking about its temperature and it is given that its initial temperature is 100 degrees centigrade. Now what we are seeing next, that this cup of coffee is placed in a room whose temperature is 15 degrees centigrade. Means this cup has been kept in a room whose room temperature is 15 degree centigrade. Means this 15 degree centigrade is the temperature of surrounding medium. And it cools to 60 degrees centigrade. Now what is the 60 degrees centigrade? 60 degrees centigrade here refers to temperature of coffee. Now the temperature has decreased. It has decreased from 100 degree to 60 degree, and in what time? In 5 minutes. Be very careful about the units. They are saying that within the 5 minutes, the temperature has decreased from 100 degree centigrade to 60 degree centigrade. Now what we have to find out? We have to find out the temperature after a further interval of 5 minutes. What we mean by this, after a further interval of 5 minutes? Means, if I explain it here, we have, suppose this is our room. We have here a cup of coffee. This room temperature is constant and this room temperature is 15 degree centigrade. Initially, the temperature of coffee is 100 degree centigrade. If I use the notation of capital T for the temperature of coffee, it means that at time T equal to 0, this temperature is 100 degree centigrade. And after time interval of 5 minutes, this temperature decreases. T refers to temperature, and now time is 5 minutes. And now the temperature according to our problem is 60 degree centigrade. Now they are asking what will be the temperature. They are asking what will be the temperature. At what time they are asking? After a further interval of 5 minutes. Means further interval of 5 minutes. So if I take it from initial, it means they are asking that what will be the temperature of coffee after 10 minutes. So this is the thing which we have to find out here. So from here we can see that this problem is based on Newton's law of cooling. So let us solve this problem. We have considered all the things which are given in our problem. So let us move ahead for solving this problem. So first thing which we will be writing here, this is the problem based on Newton's law of cooling. Let us assume some notations. Let T, capital T, be temperature of coffee. T be time, and T naught be the temperature of surrounding medium, which is here room temperature. So let us write the things which are given in our problem. Initial temperature of the coffee is 100 degree centigrade. We have discussed right now. After 5 minutes, the temperature reduces to 60 degrees centigrade, and the temperature of surrounding medium, the room temperature T naught, which is constant, is given in problem as 15 degree centigrade. And what we have to find out? This we have to find out. This is the thing which we have to find out, temperature after 10 minutes. Now, let us consider the equation which we used to have in Newton's law of cooling. Let us name all these things which are given as equation 1. Now, according to Newton's law of cooling, we have rate of change of temperature of body, which is this derivative. This is equal to some constant K, and the difference in the temperatures T minus T naught. We have already discussed in our previous video that this is a differential equation of first order, first degree, which can be easily solved by variable separation. So that is Let us put here the value of T naught, dt, this, minus K, and the room temperature is 15 degree centigrade. Let us separate the variables. Rearranging, let us name this as equation 2. We get this. We are bringing the terms containing capital T on the left hand side and minus K dt. Now we have separated the variables. Now for solving this differential equation, let us integrate on both sides. Integrating on both sides, we get the integration on left hand side will be log. We can see here when we will be integrating 1 upon T minus 15 with respect to this capital T, it will be log of T minus 15. It will be log T minus 15 equal to, let us see again our equation. This minus K, this is a constant. The integration of 1 with respect to T will be T. It will be minus KT plus constant of integration C. So let us name this equation as we have already named second. So let us name this as equation number 3. Now we will be finding the value of this constant C using the given conditions. Now using initial temperature of coffee is 100 degree centigrade. Using this, in above equation third, we have log, capital T we will be putting 100. Time, we are considering time as 0, initial, and C. This will give us that C will be log 85. This one. So let us name this as equation number 4. So let us put the value of C in equation third. From third and fourth, from equations third and fourth, we get what we get? Log T minus 15. Let us take the terms of log on one side. Log 85, this is the value of constant C, and minus T. So let us name this as equation number 5. So if I see our first equation, this one. So this condition we have used. Now we will be using the another condition, this one, that the temperature after 5 minutes is 60 degree centigrade. So let us use this condition now. Using temperature after 5 minutes, it is given that this temperature is 60 degree centigrade. In equation 5, we have let us put here the temperature as 60 degree, means here we will be putting 60 degree capital T, minus 15 minus log 85, and this is time is 5 minus 5 K, that is log 45 minus log 85 equal to minus 5K. And let us name this as equation 6. We have this equation 5. This is equation 6. If I divide these two, equation 5 and equation 6, this K will cancel out. And we will be having an equation which will be involving capital T, temperature of coffee, and small t, the time. So from equation 5 and 6, we get log T minus 15 minus log 85 log 45 minus log 85. This will be equal to minus KT, and this will be minus K5. That is, K minus K will cancel out. Log T minus 15 minus log 85 and log 45 minus log 85, it will be T upon 5. Now let us name this as equation number 7, which gives the relation between temperature of coffee and the time T. Now we have to find the temperature at time T equal to 10 minutes. Put T equal to 10 in equation 7. What we will get? We get log T minus 15 85, and when I put here 10, it will be reduced to 2, and log 45 by 85. If I remove log from both sides, I will get T, the temperature of the coffee, at 10 minutes. After 10 minutes, T minus 15, 85, and this will be 9 by 17, 9 by 17. Solving it, when we will simplify it, we will get that the temperature will be 38.82 degree centigrade. So the temperature of the coffee after 10 minutes will be 38.82 degree centigrade. Temperature of coffee after 10 minutes is 38.82 degree centigrade. So this will be our answer. We'll be considering another problem in next video.